So there's two parts to today's note 7.2. The first part is actually solving equations and inequalities that are exponential equations and inequalities. So number one, 2 to what power gives you 8? You know the answer is 3, right? So you already know the answer is 3 for the first one. But what I recommend you to do is to look at this base and see if you could change this base to be the same exact base. So 8 could be rewritten as 2 to the third power. And now that you have the same base right here, 2, and the same base right here, 2, technically you could ignore the 2's or cancel them out, and you end up with your new equation, x equals 3. And that's how we get x equals 3. So I know you're probably thinking, why the heck do I want to do that if I could just look at the original equation and see that 2 to the third power is 8, right? Same thing with number 2. Number 2, what's your answer going to be? 5. So yeah, mental math works. X equals 5. You're done. But I would like you to get into the practice of taking the 32 and rewriting it to be 2 to the 5th power. That way you could see that this base is 2 and this base is also 2, which means that you could cancel out the 2's and write your new equation as x equals 5, and that's your answer right there. Because number 3, as you could see, you can't really do mental math on that. I mean, maybe somebody could, that'd be impressive. But you're thinking, 2 to what power? And I'm not even talking about what power, I'm talking about 3 times a certain number minus 4 as the power will equal to 32 to that same number that you plugged in on the x position on the first one. Dang. Okay. Go buy a lottery ticket. The answer is 3. So my point is this. What I would like you to start doing, okay, and we all need to do this. We need to follow these steps, guys. Step 1, make both bases the same. Step 2, cancel bases, write your new equation with the exponents. Step 3, solve. Okay, so we do have a base 2 here, so it would be nice if we could change this one to base 2 also, right? So let's change the 32. It might be a good idea to put that in parentheses. That way you could actually see how it works. 32 is really what? 2 to what power? 5. 2 to the 5. So you really have 2 to the 3x minus 4 equals 2 to the 5, but it's also to the x power, which means that when you have a power to a power, you multiply them and you get 5x, right? So you really have 2 to the 3x minus 4 equals 2 to the 5x. And now that the bases are the same, you know you could just eliminate them. And your new equation becomes the exponents. 3x minus 4 equals 5x. And that becomes a new equation that you could solve, right? So how are we going to solve this guy? We're going to move the x's to one side and the number to the other. Let me make some space. So we're going to move the x's to the right. I want to subtract 3x, cancels, subtract 3x. Bless you. We're going to have negative 4 equals 2x, which means that on our final step we divide by 2, which means that negative 2 equals x, x equals negative 2. Does that make sense? X equals oh wait, the answer is not 3, so it's negative 2, so you were unlucky. Yeah. So how could we be sure that this is the correct answer? Well, technically, you could go back and plug it in, right? So let's think about this. Let's go back to the original problem and plug in a negative 2 right here. Now, if I did plug in a negative 2 right here, that would be negative 6, and negative 6 minus 4 would be negative 10. So on the left side, you really have 2 to the negative 10 power. Just to, you don't have to double check, but just to show you that it works, or to verify that we have the right answer. We have 2 to the negative 10 on the right side, and if we also plug in negative 2 right here, we'd have a 32 to the negative 2 power. Now we know that 5, or 32 could be rewritten as 2 to the 5th, so you would have 2 to the 5th to the negative 2, and we know that that would be negative 10 also. So you verified that they're equal to each other. The left side's 2 to the negative 10. The right side's 2 to the negative 10. Make sense? So let me jump to the steps again. These are the 3 steps that you're going to have to do solving any exponential equation or any exponential inequality also, okay? Any exponential equation or any exponential inequality. You want the bases to be the same. So we're going to have to manipulate bases using exponents. You manipulate bases till you have both sides, the bases are the same, and then you could cancel out the bases, then the exponents come down, and then you could solve your new equation. Let's try it on the worksheet that we have for homework. So this is our worksheet 7.2. Our quiz will involve these types of questions, solving equations and solving inequalities. So if I look at number 1 on our worksheet, it says 25 to the 2x plus 3 equals 25 to the 5x minus 9. You want the same base. Do we have the same base? Yeah. Yes, so we don't need to manipulate anything. All right? All we do is just cancel out the bases, and we have a new simple equation, 2x plus 3 equals 5x minus 9. There is no more exponents. It's a nice simple equation that we could all solve. All right? Now if we solve this equation by subtracting 5x, you're going to have a negative 3x. And then I'm also going to do 2 steps in one. Subtract 3. You're going to have negative 3x equals negative 12. And of course, when you divide both sides by negative 3, you're going to get the answer x equals 4. Super easy. Now, some of you might be thinking, wait a minute, I could change the 25 to become 5 squared. And I could change this 25 to become 5 squared. And you'll have the same base 5 instead of the same base 25. That's totally fine, but it's just more work, right? If you were to change the 25 to a 5 squared, then you'd have to distribute the 2 to each of those terms. And over here, same thing. If you change it to a 5 squared, you'd have to distribute the 2 to each of those terms. You'd get the same answer 4, but that's just a lot more work. I wouldn't do that. I would just, you already have 25 as the base on both sides. Just cancel out the 25s and move on. Let's go to something that's a little more challenging, like number 4. Number 4, you have the base 4 and you have the base 8. You need to change those bases to become the same base by manipulating using exponents. So, in other words, 8, could I change that to 4 squared? No, because 4 squared is not 8. All right, so what am I going to do? I want to change both of them. Well, I could change 4 to become what? 2. So let's change this 4 to become what? 2 squared. And we still have the power of 3x minus 3 out here. Okay? And then we have the equal sign over here. And the 8, what are we going to change the 8 to become? This 8. We're going to change it to become a 2 to the third. Now, we still have the outside exponent of 4x minus 4 that we see up there. 4x minus 4. So keep in mind, guys, that when you have a power to a power, you multiply. Now, if you do happen to have a power of 2 to the power, which is a binomial, when you multiply 2 times this binomial, you're going to have to distribute. So you're going to have to distribute that 2. So that's really going to be 2 times 3x and 2 times negative 3. So you're really going to have the base 2 to the 6x power minus 6. And the other one is going to be base 2 to the 12x minus 12. You guys with me? 12x minus 12. And now that we have the same base 2, you could just scratch out the 2's, cancel them out. Your new simple equation will become 6x minus 6 equals 12x minus 12. And you could move the numbers to the one side, subtracting 12x. Subtracting 12x, you're going to get negative 6x. And let's do 2 steps in one. Plus 6 right here, cancel it out. Plus 6 equals negative 6. And your final step here, when you divide by negative 6 on both sides, you're going to get your final answer, which is positive 1. X equals positive 1. That's it. And you could flip the paper over, check in the back, you'll see that you get the right answer, that you have the right answer there. Now, what if it's an inequality? And what if we have fractions? Like number 7. Number 7, let's say you wanted to solve this guy. Well, first of all, you have the base 6 over here. Is there any way I could change this to become base 6? The 36 could be changed to 6 squared, right? But this entire base is still a fraction. And you don't want it to be a fraction because after all, this base over here is 6. Okay? So what you want to do is get rid of the fraction. It would be nice if this 6 squared were up there. And we could move from top to bottom or from bottom to top as long as we change the sign of the exponent. So in reality, this first parenthesis right here, I'm going to rewrite that 1 over 36 as 6 to the negative 2 power. Because 6 to the negative 2 power really is 1 over 36. Does that make sense? Yeah. Now we still have the outside exponent of 6x minus 3. And we still have the other part of this inequality. It's not an equation this time, it's an inequality. Is greater than, and over here on the right side we have 6 to the power of 3x. What's the rest of that thing? Minus 9. Okay, so what else do we need to do before we continue on? We don't want to cancel out the 6's yet. Yeah, you want to multiply exponents. On the left side, power to a power, you have a negative 2 times a binomial. You're going to distribute. So before distributing, let me rewrite my bases. We have the base 6 right here, and we also have the base 6 over here. Now this one on the right side is not going to change. It's 3x minus 9. But on the left side, we're going to distribute. So when we go negative 2 times 6x, that's the power of negative 12x. And negative 2 times negative 3, that is positive 6. Now keep in mind, this is an exponent of the base 6. Now the inequality is just going to come down between the two base 6's. And now that we have the same exact base on the left and on the right, I want to cancel out those bases. They have to be the same exact base in order for them to cancel. Then the exponents come down and you have your new inequality. So there's our new inequality. Let's just solve. Subtract 3x on the right. Cancel out the 3x's. On the left, you're going to end up with negative 15x. And I might as well do 2 steps in one. Subtract 6 over here. Subtract 6 over here. I want to end up with greater than negative 15. So my final step would be to what? Divide by negative 15. And when you hear the words divide by a negative on an inequality, you should remember to switch the inequality, flip the inequality, however you say it. Final answer is x is less than positive 1. X is less than positive 1. Ladies and gentlemen, number 10, I have to explain it quickly. You need to change both bases to be the same base. All right? So I'm going to change this to make it base 3, and I'm going to change this to make it base 3. Now you should recognize from the 9 and the 27 that 9 is 3 squared and 27 is 3 to the third. But I don't want a 3 squared in the denominator of a fraction, so I'm going to make it 3 to the negative 2, which is really 1/9. So instead of 1/9, I have 3 to the negative 2. And instead of 27, I have 3 to the third. And of course, the power to a power on both sides I need to distribute. So there are my bases that are going to ultimately disappear, and my new exponents will be 4x minus 14 and the other exponent 18x minus 36. Now because we have the same base, we're just going to scratch them out. We're going to have the new inequality that reads this is less than or equal to this. Let me move it to the side and rewrite that thing. Whoa, accident. So on the left side, you're going to have, if you subtract 18 on both sides, you're going to have negative 22x. If you add 14 to both sides, you get 22. And your final step would be to divide by negative 22, which means that your final answer will be x. You have to flip it because it's dividing by a negative, positive 1.